flying saucer.
So this is what it looks like, the winding with the 8 turns per coil, all north, so it's about 1.0 on each pair. I took it apart for cleaning and checking out contacts. Okay guys, so here we go with the two batteries. They are 2200 milliamps, 1.2 volts, and a generic brand. They are nickel metal hydride, and total output, it's on that meter of the battery. Total power is 2.576, and I have the tachometer on zero. I have the DC reset to zero, and this is the output meter. It'll be showing the output from the motor. And all I did is to connect this is a 4700 UF 35 volt cap, electrolytic polarized. So we're gonna start running the motor, watching the RPMs, how they go up, and basically I had a little issue with this previous runs I have done with the motor, and I had to end up replacing the brush caps. Those are two new ones. I had a fast contact with output. So the point we're gonna be watching here is basically the total output, adding both voltages and seeing how the motor start increasing RPMs. This is the 8 turns 26 gauge 5-pole radio shack motor. Output somewhere anywhere in between 0.8 to 1 ohm pair. Is thicker gauge than the one comes from factory. That the one we've been using on is 30 gauge, which is the red wire. This is the green wire. So let's go for it and kick it. So it's outputting out there 800 milliamps over 850 and 1709, but it's going 11,300, but it's showing here 3.79 amps. Now when we start watching the meters, we add those two values up, and we're gonna have much more than originally we had. We are at 11.4, 3.74 steady, 3.7. But see how the battery increases, and that's the point that I want to bring up to the observation. It's this is also increasing, and that value is increasing, which is what makes this type of motors unbelievable. Instead of losing, they're gaining. It's going 1700 RPMs. Not right there is a 930 something, almost 9.4, and it comes up and down. But the point is it's not supposed to show an increase, but a decrease. And RPMs are top right now to 11.9. Let's see if we can see the RPMs closer. But it's from the point where it started. And you can see the meter climbing up. That meter there. And that's eventually, and also of course that one. They are both working on one end of the motor. So now it's at 12,287 RPMs. And it keeps going up. Average is 3.36. And you hear every now and then a little hum in the motor, changing because of the currents that is handling it within. Now temperature on the motor, it's room temperature, 88 degrees, and it's at 96 degrees. Now batteries are 93, 94, kind of warm. The cap is at 88. But I thought I'd run a video on this to show it to you, and so you guys can comment on this. I believe it's pretty interesting results. I was keep going up to 1760, 1780, while it's over there at 980. And I'm gonna disconnect it. And batteries are very fast climbing up. Average gain back to zero value. And the last clocking of the was at 12. 624. So run several videos on this, and the point is to be able. These are not fully charged batteries either, and they are normal temperature, a little bit warm. And these batteries normally get super hot when they're charging. I mean, I have chargers for this battery that has a fan underneath to keeps them cool while charging. And after you charge, you grab it in your hand, grab it, and you feel the heat. Anyway, so it's restoring the power back. And thanks for watching. All right, guys. This is the second part to our previous video, where we started that video with 2.576 volts and run the motor for like 5 minutes. And here we can see, after we got all the power back, we are at 2.573. I just went there and uploaded the video on cam and on PC, and I was reviewing it, and then I came back again. I have not obviously charged anything on the batteries. I want to run another test. I want to disconnect while I'm doing it the output meter, because so it shows that it still keeps climbing. So it means once that I disconnected, the cap will be disconnected. So to show that there's no, it's not due to the cap. That's number one. And number two, I want to show also the fact that if it shows here 3 amps, it doesn't mean it's drawing 3 amps. And this is what it comes about with this motor, that it has been kind of controversial. The motor has got handling because of the gauge. This is 26 gauge. It's designed for bigger motors, and we got very few turns, which is low resistance. I agree with that. But the generation, these batteries are 2.2. I mean, and that is burst, maximum burst amperage. That means when the battery is outputting that much, it will last a few seconds. So it is not possible that, and the simple test will be shortening the battery with a light bulb. I don't want to do that right now. I just want to run it. I'll do it at the end of this video. I just want to run it and see again the fact that disconnecting this is it's not 0.2574, and you'll see the amperage here also that we're gonna be outputting. So they haven't lost anything. On the contrary, we only lost what, 0.003 millivolts. So and it keeps gaining, it keeps resetting on this. What we're heading at, it's auto regeneration of these type of motors. This is Old North, and we got a generator and a motor that we are almost getting it designed to be, in order that the generation will be more than the input. within the same type of coils, and we'll get there. This is only 5 poles, so our purpose here is to build bigger motors and larger number of poles. And here we go. Now it's on AC. Oh, hold on 1 second. Let me clear this up. It's important. It was on AC. That's why it was showing so low. We set it to 0. Then we're gonna come back again. 3.90 on a non-recharged battery, and we are over there. This is the second video, and we are with the same batteries. We are at 1693. We are at 11.9, and we are outputting almost 1 volt. I'm gonna disconnect this from here. And we see that it keeps increasing. It keeps gaining. So, see, it goes to 90. And it's 12,330 RPMs, 3.56 amps. So, what I do with the cab, I put it on in order to be able to store momentarily the charges, so it can disperse it back through the same input, back to the battery. And that is what is going on. And we have to admit, we finally are going to have to come to a point that we accept that within the same wire we got dual currents traveling, not only one. So let me connect it back, and of course we're going to see small gain because it's the output. It's favoring. $9.67. It'll take a little bit. 12,000. See, climb up, keeps going up now, and again, I believe it's a very important game in this design, and I don't want to run it for too long. Still at 3.29 amps, and the motor should be burnt by now with that amperage, you know. Or decaying incredibly RPMs, and it's not gaining. It's gaining. You can see 12.37 to 12.4. So it's actually gaining. And you can see there we got almost 1 volt there. So. 1736. Now I'm gonna disconnect it. I don't want to make too long of a video here, and I want to test this light bulb here. And again, this light bulb, it's got very low resistance. Of course, it's an incandescent automotive bulb, 12 volts. I mean, this is an animal compared to these batteries. We are overkilling these batteries with this bulb. This is automotive, and this is for, it can stand the high amperage in a car circuit that can raise up to 30 amps. Okay, so, and even more. But anyway, in the accessory circuit I'm referring, it could anywhere run in between 30 amps. We're dealing here with a small battery, but according to our laws, once that I short circuit these batteries with these bulb, they're gonna output maximum potential in amperage. So we're gonna do that, and I'm gonna disconnect it from here. I'm gonna put it right here so we don't lose track of it, and I'm gonna measure the resistance of these bulbs. That meter over there, and we're gonna see that it has 0.6. It's finally settling down the processor. Anyway, 0.7 ohms. It's not even 1 ohm. So that's a pretty radical short, right? So we get those batteries that we're gonna get a reading in voltage, and we're gonna measure it, and we got 2500, 2.501. Okay, so they actually lost 0.076 volts. Now let me turn this on, and we're gonna put the clamp through this bulb, and we're gonna then, don't matter here if I put positive with positive, but for the video to come out pretty, I'm gonna do it. So let me show here, I'm sure it's seen on video, and shut it up. 1.05 amps, and the bulb, you can see, is very dim but lighting up. So that's the max output that these batteries will get out at 0.7 ohms of resistance. And that's about what I have on this motor. Actually, I have less on this motor, so it could be anywhere in between, like I said before, 0.8 to 1 ohm. Sometimes when the copper gets hot, it has a tendency to either go down in resistance or go higher, depending on the number of windings and depending on the configuration of the windings. So thanks for watching, guys.